Anytime you have a monomial and a rational expression, break it down into its two parts, writing both over whatever your denominator is, which is secant squared. Secant squared over secant squared, and anytime I divide something by itself, I get 1. 1 over secant squared. Anytime I have 1 over something, I should think of reciprocal identities. The reciprocal of the secant is cosine. You move it from the bottom up to the top. You end up with 1 minus cosine squared, which comes from reciprocal identity. And then using Pythagorean identities, remember 1 minus cosine squared is sine squared. Boom, you get the same thing. Okay. Second one, if you happen to fall upon sine squared plus cosine squared, okay, sine squared plus cosine squared as a Pythagorean identity is 1. Okay, so that's my Pythagorean identity. And then those, ladies and gentlemen, are going to be reciprocals of each other. Cosine squared, secant squared. Alright? So basically you can pick either one, whether it's cosine squared or secant squared, and move it from the bottom to the top. If I move the secant squared from the bottom to the top, I rewrite it as its reciprocal, which is cosine squared. So then that becomes cosine squared over cosine squared. And anytime I divide by itself, I get 1. Alright, on the bottom I got more rational expressions. And two things. Number one, there's more than one. Number two, they're not monomials, so I think of conjugates. Alright? But before that, I think of common denominators. The easiest way to do it is take whatever the numerator is and multiply by the opposite denominator. So I'm going to take 1 and multiply by 1 sine alpha, and then the other 1 and multiply that times 1 minus sine alpha. Alright? That's all over the common denominator, which is now 1 minus sine alpha, 1 plus sine alpha. 1 times 1 is 1, 1 times 1 is 1, 1 plus 1 is 2. 1 times sine alpha is positive sine alpha, 1 times negative sine alpha is negative sine alpha. Sine alpha plus negative sine alpha cancels out. When I multiply those through, 1 times 1 is 1, 1 times sine alpha is positive sine alpha, negative times 1 is negative sine alpha, they cancel out, just like they do on the top, and I end up with 1 minus sine alpha squared, or sine squared alpha. 1 minus sine squared is equivalent to cosine squared by Pythagorean identities. Alright, and then whenever I have something in the denominator, I can move it up to the top using the reciprocal or inverse. The reciprocal or inverse of cosine is secant. So that's 2 secant squared. And now my two expressions are exactly the same. Similar idea. This problem is pretty much the same thing, just with a different trig function. I'll walk through it real quick. 1 times that would be 1 plus cosine beta. 1 times that would be 1 minus cosine beta. Over 1 minus cosine beta squared would be the result of multiplying those, because once again the outers and inners will cancel out. These will cancel out as well, give me 1 plus 1. 1 plus 1 is 2. 1 minus cosine beta is sine beta squared. The inverse of sine is cosecant, so I end up with 2 over 2 cosecant squared beta. And then you'll notice once again they're exactly the same. Okay? I cannot stress enough, anytime you see something squared plus 1 or minus 1, you got Pythagorean identities. Cosine squared x minus 1 is the opposite of 1 minus cosine squared x. 1 minus cosine squared x is the equivalent to sine squared x, so the opposite of that would be negative sine squared x. Tangent squared x plus 1. Now we go to one of our other identities. Remember, with the other identities, the secant and the cosecant is always greater than 1, so that's always going to be by itself. And the cos go together. So cosecant goes with cotangent, so that means with tangent would have to be secant. So that helps trigger the fact that secant squared, tangent squared x plus 1. So I can rewrite that as secant squared. So it's secant squared times negative sine squared x. Secant squared using reciprocals again. When all else fails, we write it in terms of sine and no cosine. Negative times a positive is negative. Negative sine squared x over cosine squared x. Give the cosine in the denominator, sine in the numerator. And that hopefully you realize using quotient identities is negative tangent squared x. Secant squared x minus 1 times sine squared x minus 1 equals negative sine squared x. Sine squared x minus 1, the opposite of 1 minus sine squared x. 1 minus sine squared x is cosine squared x, so this would be negative cosine squared x, just like the one above it. Secant squared x minus 1, if I go back here, secant squared equals tangent squared x plus 1. You need to get in the habit of getting things in the correct format. How do you get rid of a plus 1? You minus 1. Secant squared x minus 1 is tangent squared x. That means I can come back here and replace this with tangent squared. Alright, so that's using Pythagorean identities. I would then use quotient identities. That tangent squared is sine squared over cosine squared. Negative times a positive makes your final answer negative. Okay? Cosine squareds cancel out, and I got negative sine squared, which is equal to that, so I'm good to go. So I use the quotient identity to get that one. Okay, now, the next one. We're going to go through what happens when you might want to write both. Alright, so in other words, I have nothing, no identities to use, no inverses of each other, and anything like that. So myself, I would take tangent and use quotient identities, sine x over cosine x, plus cosine x over sine x. So that's your quotient identity. Equals secant x, which is 1 over sine x, cosecant x is 1 over cosine x. Actually, I got to reverse. That's the cosine and that's the sine. Okay? Now, this is more complicated because it has an addition. So I'm going to work with that one next and see if I can get it to look like that. So basically, I have two rational expressions, so I'm going to multiply by the opposite. So sine squared x plus cosine squared x over cosine x sine x. Alright? I found a common denominator. Alright, so I multiplied sine by sine, which gave me the sine squared. Cosine times cosine gave me the cosine squared. Sine squared plus cosine squared by Pythagorean identities is 1. So that becomes 1 over cosine x sine x equals 1 times 1, which is 1 cosine x sine x. So again, keep in mind, they just have to be the same. You don't have to leave one like the way it is. Alright? Same idea underneath. Cosecant x is 1 over sine x minus sine x over 1 equals cosine x, and then cotangent x would be cosine x over sine x. This has a sine x, that doesn't, so this becomes 1 minus, so I multiply by the opposite denominator. Again, that's finding a common denominator. Sine over times sine is sine squared x over sine x equals cosine squared x over sine x. Now, basically what we're saying is the sine x's are the same. Well, Pythagorean identity is 1 minus either sine squared or cosine squared as the cofunction. So I can write 1 minus sine squared as cosine squared x. And then you'll notice they're exactly the same. Alright, so this was writing everything in terms of sine and cosine. So that was step 1. Then I found a common denominator, and then I used Pythagorean identity to realize that 1 minus sine squared is cosine squared, and it all matched up. Alright, left page. Secant x plus tangent x. Secant x is 1 over cosine. Tangent, alright, is sine over cosine. Well, look at there. Now I got a common denominator. So now I have 1 plus sine x over cosine x equals cosine x over 1 minus sine x. At that point, you have two rational expressions. I would certainly allow you, because they're two rational expressions each equal to each other, think of it as a proportion. So to do that, I can cross multiply. So I'm going to do 1 plus sine x times 1 minus sine x equals cosine x times cosine x. When I do this, they're conjugates of each other, so the outers and inners once again are going to cancel out. I got 1 minus sine squared x equals cosine squared x. And then you'll realize that by Pythagorean identities, you have identified that they are equal to each other. Alright, so for this one I use a quotient identity and a reciprocal identity. Tangent was a quotient, reciprocal was a cosine, and then I work from there. The one underneath is going to be a lot like it. Cosecant x is 1 over sine x. Cotangent x is cosine x over sine x. They have the common denominator again, so it's 1 plus cosine x over sine x. Sine x over 1 minus cosine x. And when I cross multiply, the same thing happens. Sine times sine is sine squared x. Positive times a negative. Conjugates of each other is 1 minus cosine squared x. And hopefully you recognize the two Pythagorean identity. That is the case. Alright. Cotangent squared theta over 1 plus cosecant theta equals 1 minus sine theta over sine theta. Okay. So now we're going to have some major things going on. Alright. So if I look at this, 1 minus sine theta over sine theta, this would be 1 plus cosecant theta over that. Alright, if I cross multiplied, like I did before, cotangent squared times sine equals 1 plus cosecant, 1 minus sine. Alright, cotangent squared is cosine squared over sine, squared times sine. One of the sines cancels out. I end up with cosine squared over sine. And then I'm going to try to go over here and see if that helps me. So that becomes 1 minus sine theta plus cosecant theta minus sine theta cosecant theta. Alright. Sine times cosecant are inverses of each other, so that becomes 1. So reciprocals, 1 minus 1 cancels out. So I'm going to have, when I'm all done, negative sine theta plus cosecant theta. Alright. Using trig functions, this becomes negative sine theta plus 1 over sine theta. Now finding a common denominator. That doesn't have it, so I got to multiply by it. So that becomes negative sine squared theta when I'm done multiplying, plus 1 over sine theta. Negative sine squared plus 1 is the same thing as 1 minus sine squared. And hopefully you realize 1 minus sine squared is cosine squared over sine. At that point, you notice that's cosine squared over sine. This one is cosine squared over sine. So basically they're exactly the same. And then the last one, tangent squared over 1 plus secant equals 1 minus cosine over cosine. So you can tell there are a lot of likes. Pretty much it's going to be the same method. Tangent squared cosine theta equals, from FOIL, when I multiply, so I'm cross-multiplying, 1 times 1 is 1, 1 times negative cosine theta is negative cosine theta, secant theta times 1 is positive secant theta, and then secant times negative cosine secant. Alright, just like in the previous problem, since cosine and secant are reciprocals, it's 1, 1 minus 1 is 0, so this becomes negative cosine theta plus secant theta. This becomes negative cosine theta plus 1 over cosine theta. using quotient identity, using reciprocal identities. When I multiply to find a common denominator, I get negative cosine squared theta plus 1 over cosine theta, which when I'm done is 1 minus cosine squared theta over cosine theta, which is sine squared over cosine theta. Alright. I come over here now, tangent squared times cosine, sine squared over cosine squared. Whenever I have something squared in just that thing, it cancels out the square, so I end up with sine squared over cosine, and it cancels that out and that, and then you'll realize the two expressions are exact. Alright, so that means you got to finish the other 35 on your own. That's what we're going to be working on in class Friday, Monday. Remember, they're due Monday night at midnight. And then we will talk about the quiz after you submit. You good?